Hello viewers, Assalamu alaikum. Welcome to the ETABS learning tutorials. Today is the tutorial number 1, and in this tutorial I will give you an introduction about ETABS software, how to use it, how to use different parameters, and second I will calculate the reactions of a indeterminate beam and draw the shear force diagram and bending moment diagram of that beam. So let's start. So first of all, you need to install the ETABS, or you can buy the ETABS from the CSI website, and then after installing, a icon will appear in your desktop, and just double click that icon. I would like to open the ETABS software. So this is the interface of the ETABS software, and you see only file option is working here, and rest of the options are hide because first you have to create a model or you have to start something, then the rest of the options will be working. So go to the file menu and select new model, or you can open it by Ctrl O or Ctrl N. So click the new model. After clicking new model, you see there is a sub window is coming here. New model initialization. One is choose EDB, default EDB, and no. Choose EDB is using when you select a default when you select a configuration from your existing existing ETABS file, and default EDB will be used when you will use the default configuration. But I would like to create a new model with a new configuration, so I am clicking here no. And here is window coming here, building plan grid system. At the beginning of any types of model, you first define the grid system, and the grid system is working on x-axis and y-axis, and it must be given from the plan view. So let's see our beam where we will work. This is our beam, and this is the elevation view. You see the elevation view, and we have 4 point A, B, C, D. In the A, B, C point we have support, and D point is just overhanging, and a point load is here, and the plan view is here. So I just open the ETABS. See, first you have to change the unit. First at the very beginning you need to change the units on which unit you will work. So I select keep feet because I would like to work my distance with feet and load in keep. So I select keep feet here, and then there is option coming here, number of lines in x direction, number of lines in y direction, and it must be given from the plan view. So open the plan view, and you will see in the plan view here is our x direction, and in the x direction we have 4 point A, B, C, D. So we input in the x direction 4. Here is an notes for you. This grid line or this number of line is stands for number of joint or number of support in a direction. So if we go through this direction, we see there are 3 support A, B, C, and there is ending. So you have to put 4 lines. Okay, but in case of Y, you see there is nothing here, only 1 line. So in ETABS I will input just 1. So if I have do not have the B support, then I need to input just A, C, D. That means in that case in X direction I have to input 3 lines. Also, if we do not have any this intermediate support, then I just put A and D, that means 2 lines. So here I input 4 lines because I have 3 support and 1 ending point. So let's go to the custom grid spacing, because the spacing between the span are not same, so we need to input the distance, and we go to the custom grid spacing, then go to edit grid, and in the edit grid option you will see display grid as. We will select spacing from here, spacing. So now I will give the just the spacing from one point to another point. So open the file. So you see the spacing between A to B is 10 feet, 10 feet, 10 feet, that means 30 feet. So I input here 30 feet, just type it 30 feet and press enter from keyboard. And the B to C is 50 feet, so again I press 50 and press enter. And C to D is 16 feet, so I press 16 and enter. And you have to do nothing in here, but when we will learn the building design, then sometimes we need to use other options. But for the initial or frame, we do not need to any other things. Then just hit OK. And in the right side of the grid system, there is option is a story dimension. So I would like to use just one story and give the story height 5, because the number of story and typical story height is not useful or is not essential for any types of frame analysis. It will be useful for multi-story building or multi-story frame analysis. So in this option, first you need to change the unit, then you will input the number of lines in x direction, number of lines in y direction, then go through the custom grid spacing and edit grid, and then input the story data and story height, then select grid only. Okay, there are huge option is here, two-way slab design, waffle slab design, flat slab design, steel deck, but we need to do the grid only option. Okay, so select grid only and then click OK. So you'll see our raw model is created here, and this option is tell us plan view, and this is 3D view. And now you'll see all other options is working here. So first I would like to introduce about ETABS options. So if I click the file menu, you will see there is new model, through which you can create a new model and also open. This option will be used to open an existing model, and here is save. If you wish, you can save this model and also save as. And there is another option, import. You can import data from Safe, AutoCAD or others softwares to ETABS, and also you can use this export command. Also you can print, and there are 4 options: print setup, print graphics. If you need to print something, then you will use these options. Also you can capture some DXF file, and the rest of them we should not use. And also in the edit tab, you will see undo, redo, cut, copy, paste, and there are option is here: merge, joint, expand joint, area. Sometimes we need to edit our model or edit our plan, and then we'll use these options. And there is a view menu here. What types of view you would like to see? Okay, there are 3D view, plan view, elevation view, and also set building view options. We will use this option later. Define, this is most important tabs for the designer. First you need to input the material properties. So if you build a building in concrete, then you will select the material here as concrete, or if you select make the building in steel, then you will select the material in steel. And also rest of the options is here. And also there is option here, static load case. When you will input the load, you will select or use these options. And there are also seismic, that means earthquake option is here. So gradually we will learn all of these options. And the next command is draw. By using this command, you can draw beam, slab or column, whatever you wish. And there are also other options here, select menu, by which you can select individual beam or plan or individual stair. And next is assign, by which you can assign the properties, assign the load, assign the support, assign diaphragm, and other option. And next is analysis. First of all, after creating the model, you have to run the analysis to see the support reaction, shear force diagram, bending moment diagram, or stress or also deformation. And also there is an option display, how you would like to display your analyzed model, or which result you would like to see. and the last option is design. Within using this command you can design a concrete structure or steel structure or even composite beam structure. Okay, so let's start. First I need to draw four beams here, then I will assign the support, and then I will give the loads, and then I will analysis. And next you will see the reactions and shear force diagram, bending moment diagram. Okay, so start with me. So first you need to select one window in plan view and another window in elevation view. You see the left window is selected as plan view and the right window is 3D view, but I would like to select or change this window in elevation view. So click on the any place of that window and go to the view option and select elevation view. In that way you can bring it, or sometime the shortcut is given in that here. So I select this window and select elevation, and here I will select 1. So this is our elevation view and this is our plan view. So next your task is to create the beam. Okay, there are two ways to create the beam. Just go to draw line object, and you will see there are three options: draw lines, create line in region, add click, create columns, create secondary beams in region, or add click. So if you select the first option, you have to work on plan, elevation, or 3D, and in the second option it will also work on plan, elevation, 3D. Most of the cases we will use first two options or these two options to create the beam, and the third option we will use to create the column. Okay, first two option we will use to create the beam, and the third option we will use for the columns. So I select the first option, draw lines. Okay, just simply click on that point, and then another window is coming here, properties of the object, and this option is not essential for us to analyze the frame. Okay, but in case of beam this is a vital component, but for the frame, and this is our very first tutorial, so we would not change anything here. So just leave them as it was. So now I will create the beam. So first select on the grid point A1. Okay, when your cursor move your cursor to the grid line, you will see some point is here. So select here, then here, just click on left, so left button, and again here, and again here. Okay, then press escape button or click in this arrow. So our frame or beam is created, and now I need to assign the support. Okay, so look out our plan. At A point there is a fixed support, and B and C there is a roller support. Okay, so select the A point. You can select any of here. You can select in plan view or you can select in the elevation view. I select the plan view. Okay, just I am clicking here, see, and then go to assign, then go to joint point and resting. So I am keeping here. So first I just select the point where I need to input a support, then I go to assign, then I go to joint point, and then I go to restraints or support. Okay, and there are four types of support is here. First one is fixed support, hinge support, roller support, and internal hinge. You need to input the fixed support, since at the first point I have hinge fixed support. So just click on the fixed and then click OK, and look in the elevation view nothing is changed, but when you just move up your wheeler of mouse, you will see there is a fixed support is here. Just move the wheeler of your mouse up and down, and you will see the fixed support has already assigned. So next at the B point and C point are rollers, so I select B and C at the same time, and then again go to assign, joint or point, restraint or support, and select the ruler is the third point, or you can see here, and then OK. So ruler support is also given. You can zoom that point by selecting this option, rubber band zoom. Just select this point, look, so ruler support is given here. So we have create the beam, we have provide the support. Now I need to provide the loads. Okay, so we have two loads in ABA span, 2-point load. Just to insert the load in a specific span, first select that span. So for AB span I select AB, and then go to assign, and then go to frame or line load, and then go to point load. You can see in the assign option, uh, there is option for frame or line load, and under that option we have point and distributed. So if you wish, you can input the point load and distributed load, no problem. So I select point, since at the AB portion we have 2-point load. Okay, so there is an option is coming here, frame point load. So there are also option is here. First you need to select the load case name, we select live. Okay, for frame analysis we select live, but in case of building you may use live, floor finish, partition wall, whatever. For it is a beam, we select the live and select the unit for keep fit, and there is option is here, force or moment. We can input both force and moment, and in the bottom there is option relative distance and absolute distance. You have to select the absolute distance because we would like to input through this distance, absolute distance. Okay, so our first point load is at 10 feet from the left end. So this distance is measured from the left end, okay, from the left side. So first distance is 10 and load magnitude is 100, and the second load is from left side, 10 plus 10, that means 20 feet distance, 20 feet away. So I give 20 feet away, and the magnitude of the load is 100. Okay, so here is an important issue, that these distance are measured from the left side. Okay, always from the left side, or in case of vertical, from the bottom side. So our first load is here and it is from the left side at 10 feet distance, and second load is here from left side 20 feet distance. Then click on OK, and you will see two loads is assigned here. Okay, so two loads already assigned here, units is not showing. Anyway, next our task is to assign the distributed load at the span B to C. So select the span B to C, just click on the beam, it will be selected, then go to assign, frame or line load, and select distributed. Since at the B to C we have distributed load. Okay, so select the distributed load, again change the load case name, live, unit, keep fit, and absolute. Listen, there is an option here, okay, trapezoidal load and uniform load. If your beam has uniform load from A to B, then you can select this uniform load option. But if your beam has triangular shape load or any trapezoidal shape load, or distributed load is not continuing throughout the span, then you will have to select the trapezoidal loads. Okay, but in case of our beam we have a distributed load and it is throughout B to C, so I select 5. Listen, I do not input the units. Okay, already the ETABS select the load as keep and distance as feet. You just need to input the value. Okay, if your unit is 5 keep feet, then you will select here keep feet and input the value. Okay, then keep OK, and you will see our distributed load is also inputted here. So our loads is assigned. Now we have only one load remaining, it is 25 keep at C to D point. So I select that beam, go to assign, and again point load, and it is live. You see the distance is 16, So I select here the distance is 16 and the load is 25 and rest of them will be 0 0. So here is an one question that when you select a beam, then your distance will measured only for that beam. If you measure the distance d from a point, then your result will not be correct. You have to measure the distance from the c point in case of the load assignment. So since I have selected the CD beam and at a distance 16 feet, our load magnitude is 25. Then just simply click on OK. So here we go, our load is fully assigned. And next you need to analyze your structure to know the reactions and shear force diagram and bending moment diagram. To do that, go to analyze and select run analysis. There are also two other options, set analysis options and check model. We do not need to perform this option in case of frame. We will use or see during the building analysis. So just click on the run analysis. When you will click on the run analysis, then the option will appear to save your document. I would like to save the document at the desktop, and in the desktop I just would like to create a new folder and I name it lecture 1 and I save the file name as lecture 1. Then just simply save it, and the ETABS will analyze your model. So during this analysis, I would like to say that I will provide some more tutorials for the beginner engineers who would like to learn ETABS, and all of these tutorials will be useful or helpful for the student or for the undergraduate student who is doing a course named Structural Analysis and Design Lab 3 also. So if you find or found my videos useful, then please click on the like button and also subscribe, because if I do not have sufficient subscribe, then maybe I will not continue these tutorials. So please subscribe my video. Okay, now I would like to see the reactions, right? So to see the reactions, you need to go to the display and then go to the show member force or stress diagram, and there is one option is support or spring reaction. To see the reactions, you need to go to the display and then go to show member force or stress diagram and then support or spring reaction. To see the reaction, you need to go to the display, show member force or support reactions, click here, and there is option load, dead load, but we input all of our load as live load, so we select live here and then OK. So reaction is coming here, but it is not showing. To see the reaction, you have to click the window and select the 3D. Okay, just click the 3D. Now you'll see the reactions. I just need to zoom. There is a rubber band zoom. Use the rubber band zoom to zoom a point. Okay, just rubber band zoom. See, here is our reactions, and there is option there, rotate 3D view. Click on the rotate 3D view. You can rotate your structure and see the reactions value, and you see the vertical reaction is 76.85, and there is also a horizontal reaction. We no need to know the horizontal reaction, whatever. And also in the mid span, our reaction is 262, that means at the point B, and at the point C our reaction is 135, and all of these reactions are comes in keep unit. You will see the unit in here. Okay, you will see the unit in here. There is a keep ins, that means all of the reaction or loading value is showing in keep value, and the distance is in inch. So our next task is to see the shear force diagram and the bending moment diagram. So I would like to see the shear force diagram in that window. I just select that window, elevation 1, and then go to display, show member force or stress diagram, and frame pier spandrel forces. You have to select frame or pier or spandrel forces. Just click here, and there is option is coming here, member force diagram for frame. You select live static load and you select in plane shear, because since the beam has three dimension, okay, x axis, y axis, and z axis, but we need to see the shear force diagram. We have to select the in plane shear, and we no need to do anything in the scaling factor, but in option you select unchecked the field diagram and check the show values. And since it is our frame, by default the frame will be tick mark, then click on OK. So this is your shear force diagram, and I also bring the bending moment diagram in the right side. I select the right window, elevation 1, to select the elevation view, and then go to display, show the member force or stress diagram, frame or pier or spandrel forces, and again select static light live static load and select the in plane moment, and in the option uncheck the field diagram and check the show values. Okay, in just click on the in plane moment and uncheck the field diagram and show the values on the diagram. Click OK. Our bending moment diagram also here, but the diagram is just opposite which we consider in Bangladesh. Okay, so to do the correction you need to go to the option and then moment diagram on tension side, just untick mark. Okay, this is our shear force diagram, and this is our bending moment diagram. If you zoom it, you'll see, I just would like to change the unit here, keep fit. Okay, you see our shear force diagram is this like, because there are some load is here, one load is here, one load is here, so the diagram is changed here. And then we have a distributed load, so the diagram of shear force is like that. And then we have an overhanging load here. And in case of bending moment diagram, look at the S support, we have a fixed support, so we have a moment here, and at the B joint we also have another moment, and at the C point we also have another moment. So here is the shear force diagram and bending moment diagram. Sometime you may need to find out the shear force at a specific distance. Okay, look, our B to C span is 50 feet, but I would like to see what is the shear force at just 10 feet distance from the B point. Just right click on the beam and you will see a small window is coming here. Here is distance and here is the value. So at 10 feet you can write here 10. Okay, and you see at the 10 feet your shear force value is minus 89. Okay, so how you can do it? Just right click on which span you need to see the shear force value. Just right click and enter the distance. Look, 5 feet the value is. And the same thing is happening for the bending moment diagram too. In case of bending moment diagram, just right click on that span, and now if you move your cursor here, then the value also changed, or you can just input the distance and the value will show here. So that's for today, and I know my English speaking is not so good, but I will try to improve that. And I also urge you to please subscribe my channel and like my video. If I get sufficient like and video, I will upload the next video very quickly. And my mission is that I will upload or cover a full tutorial for the ETABS, from the frame analysis to the building analysis, so you can design or you can analyze the building through my tutorials. I would like to give thanks to a special person who teach me ETABS or also the building analysis. First, I would like to thanks Professor Dr. Tohur Ahmed sir, professor of Russia University of Engineering and Technology, Ruet. Tahur sir first teaches us about billing analysis, and we have a course on it. And second, I would like to thanks engineer Ahmed Kabir Bhai. He is my present colleague at UITS, and he's a Rajuk numbered or enlisted engineer. So thanks to them, and a special thanks goes to Allah Almighty. So thank you.